Well, good morning, everyone, and welcome to the Fiber Broadband Association's Five for Breakfast. We're now in our 42nd episode of 2023. But before we kick off, I'd like to thank Wesco, the platinum sponsor of Five for Breakfast, and our gold sponsor, Network Connects. And today is our second episode of our Quantum series, sponsored by Qubitekk. So in Washington, D.C., Representative Jim Jordan of Ohio is still trying to rally votes for Speaker of the House. In yesterday's vote, Jordan lost 20 Republicans in the first round. The next vote is scheduled for today around 11 a.m. So the House needs a speaker, and until one's elected, legislation cannot be passed. And additionally, the short-term budget runs out on November 17th. So there's going to be a lot to be accomplished in a short period of time in D.C. And yesterday, the House Committee on Energy and Commerce sent a letter to FCC Chair Jessica Rosenworcel. The letter expressed their disappointment and opposition to her announcement that the FCC will vote to reclassify fixed and mobile broadband as telecommunication services under Title II of the Communications Act. They go on to say that not only is this bad public policy, but it's also unlawful. And reclassification and the associated heavy-handed regulations that accompany this action continues to be a solution in search of a problem. Today, the Fiber Broadband Association is kicking off its inaugural 2023 Fiber Deployment Costs Study Survey. The survey is to understand the cost of deploying fiber in various geographic and construction scenarios. So the survey's results will be anonymized and aggregated and published in a report in December, with the goal of providing the fiber industry with reliable and accurate cost benchmarks. So if you're interested in participating in this survey, you can find the link in our chat. Please do, we'll send out some emails and so forth. So we really want you to participate. So we really want good cost data. And next Tuesday, October 24th in Minneapolis is our final Regional Fiber Connect workshop for 2023. Please register today as we look forward to seeing you in Minneapolis. And that brings us to today's Five for Breakfast session. Today is our second episode of our Quantum series, sponsored by Qubitekk. Today's guest is Nicole Barberis, the Director of Quantum Business Solutions with IonQ, to discuss the remarkable quantum computing impact and its implications for solving complex problems in areas including optimization, machine learning, drug discovery, finance, to name a few. But before I formally introduce today's guest, I'd like to introduce Trish Ehlers from our team, who's going to walk us through some housekeeping items.
Thank you, Gary. Good morning to everyone who's joined us this morning. Before I do go over a few logistical items, I'd like to once again thank Qubitekk, our sponsor of our Quantum series, our platinum sponsor of Fiber for Breakfast, Wesco, and our gold sponsor, Network Connects. Now, if you'd all keep in mind that you're in listen mode only, to ask a question, you can type it into the question box in the control panel on the right side of your desktop screen. We'll host a Q&A session with our panelists at the end of today's webinar. This presentation is being recorded and will be available on FBA's website within 24 to 48 hours. You can find the recording in the Events tab under the Fiber for Breakfast drop-down option. At the conclusion of today's presentation, you will be prompted to complete a very brief feedback survey. Please take a minute to do that. We truly appreciate your input. I'll pass it back to Gary now to introduce our panelists and get us started. Gary?
Well, thanks, Trish, and good morning. I'm Gary Bolton, the President and CEO of the Fiber Broadband Association. Last week on Fiber for Breakfast, we had the pleasure of hearing from our good friend and strategic partner, Mike Render, the principal of RVA Research, who discussed his latest research, which reveals that fiber is preferred by nearly 2/3 of all internet users. The study revealed that fiber has gained 15 percentage points in market share over the past 2 years, taking 14 market share points from cable. Fiber availability has also added 3.2% to the value of the price of condos, nearly 5% to the home value for a single family home, and nearly a 13% premium on rent for apartments. So fiber is definitely helping our housing market. Today on Fire for Breakfast, our guest is Nicole Barberis, the Director of Quantum Business Solutions with IonQ, to discuss quantum computing impact and its implications for solving complex problems. Nicole is the Director of Quantum Business Solutions, where she and her global team focus on collaborating with clients on their journey to implement quantum computing applications. She brings strong technical background in classical and quantum machine learning that she uses to help IonQ's clients choose the right quantum applications to implement. In collaboration with business domain experts, with an MS in applied statistics, Nicole spent over a decade working as a data scientist. Prior to IonQ, she worked at IBM's Quantum team as a quantum machine learning developer. Nicole is focused on helping clients succeed in getting production ready with their quantum applications. There's a lot happening in quantum computing these days, so reach out to Nicole with any questions, because she likes nothing better than discuss how to make you successful in the quantum era. So welcome, Nicole. And for our audience, please type in your questions as we go, and we'll work them into the Q&A. So let's go ahead and get things started.
Thank you, Gary. So first of all, also I'd like to extend my thank you to the sponsors. A warm welcome to all of you from IonQ. We build quantum computers from ionized atoms, right? Next slide. And along with building excellent quantum computers, we're also focused on full stack applications. In fact, Time Magazine selected us as one of the 100 most influential companies. So a little bit more I wanted to add, Gary, thank you for that introduction. I think for this audience, they'd also like to know that I have a long history in IT. I started as a firewall administrator and network administrator, and from there, was introduced to big data, and from there evolved into a data scientist. Along the way, I was inspired by David Deutsch to get involved in quantum computing. So I've been actively involved in the quantum computing field for about 10 years now, including a patent when I was at IBM Quantum on their quantum machine learning development team. I've been with IonQ for about 2 years, and as Gary mentioned, I spend my days talking about use cases, inspiring clients. We have a large list of clients, including Airbus and Hyundai, which I'll share with you in one of the slides. So on the next few slides, I'm really going to share with you why IonQ is different and how this is relevant to your environment, right, to the IT landscape that you're part of. Next slide. First thing, I'd like to, in a very practical way, give you the definition of a quantum computer, right? You're going to be on the internet, you're going to see very complicated explanations. This is very practical, right? A quantum computer offers 3 additional operations, and I mean from a developer's perspective. I mean Python code that you can actually make use of in a program. And these operations are quantum superposition, entanglement, and interference. Interference in particular is really the powerhouse behind what is making quantum applications useful and approaching being useful in the market. In fact, IonQ is focused on commercial enterprise-grade applications. Our roadmap is accelerated relative to other vendors, and I'll tell you a little bit more about that in the next few slides. So why is IonQ winning in the market? This is my elevator pitch, right? So this is what I'd like you, if someone asks you, your friends, your colleagues, these are the 3 main reasons why IonQ is winning so many clients. Number 1, we use naturally occurring ions, right? These are atoms that have been ionized. We're using ytterbium ions right now. We plan to use barium. These are naturally quantum objects. Unlike other platforms, other architectural paradigms, we're not manufacturing the qubits. So in the superconducting framework, each qubit is individually manufactured, and you can imagine all of those electronics introduce errors at a very fundamental layer. Given that we're using atoms, ionized atoms, these are naturally quantum objects. That helps us lower the errors, meaning that myself as a developer have better results at the end of my program. Number two, our chip design is very flexible. The ions are held in a vacuum with electromagnetic forces in a chain. There's no wiring in between them. This means that in the future, if a client were to approach us and say, can you change the design, the chain of ions a little bit, right? We're able to do that. Unlike other manufacturers, the qubits are not hardwired together with capacitors. Very, very flexible design. And third, the modular and scalable architecture. What you see there in the image, those green boxes those, you can consider those chips. And these chips are going to be connected together with optical fibers. And then the machine there you see is just a traditional data center multi-port, fiber optic station. So you can see that our roadmap is headed towards modularity, getting smaller, and really fitting into commercial data centers. What I'd like you to take away from this slide is no fundamental research is needed. All of this has been solved in the lab. We're in the process of manufacturing this. Next slide. Now, for those of you a little bit more visual, I want to show you, you see here on the left, IBM's conception of a quantum computer where a human is inside that casing. That's a casing for a dilution refrigerator. In that design, the qubit needs to be very, very cold. In fact, colder than anywhere in outer space. And while this is an amazing feat of, of engineering, it's also very expensive. You see in the middle, Google's conception of a quantum computer. And then on the far right, IonQ, the box in the back is a little bit higher than a human, and it's getting smaller and smaller. In fact, what that individual is holding, that's where the chip is. And we're moving towards just smaller and smaller modular design, in fact, room temperature. So what I'd like you to take away from this slide is IonQ does not require any dilution refrigerators. Next slide. So in this desire of ours to move towards smaller and modular systems, this is a new facility we just opened in Seattle to manufacture rack mountable systems. And I have a picture of what our vision of these would look like. Next slide. So this is our system called Forte Enterprise, which is in the works. We are expecting to deliver on this in 2024, so next year, which brings home what I mentioned earlier, that our roadmap is very much accelerated compared to other quantum computing manufacturers because of the nature of our qubits, right? Our qubits offer very low errors. With that, we're able to process programs, right, and give some nice results to clients. It's true that these results now are prototype results. We're focused on the design of the circuit. Then as we have more powerful computers, we'll process more data. But the design of the actual program is core to the success of our clients' journey as they move along in quantum computing. So this is one step in that direction where we're getting production ready and working with clients to help think, how is this going to work? How is this going to fit into your data center? How is quantum computing going to fit in your current infrastructure and pipelines, like program pipelines that you have already in your company? Next slide. So continuing on with the roadmap, you'll see here in 2023 a little green check under 29 or next to 29. This is the number of qubits that we offer currently. These are very good low error qubits. Now, you may think, well, what about other manufacturers? They're making available 433 qubits, or D-Wave has 5,000 qubits. What I'd like you to take away from this slide is that the quality of the qubit really matters. If you have low error qubits, you can do a lot with just 29. In fact, we've delivered work for Airbus and Hyundai. So every company has a different roadmap, right? There's no global solution on how to make a quantum computer. And you'll see here in 2024, we're focused on 35 qubits. In 2025, which is only 2 years away, 64 qubits. This is where we anticipate we're going to cross the line and surpass what is possible on a classical computer. We're definitely going to surpass what you can simulate as far as quantum computing simulations, right? We will not be able to simulate 64 qubits on a classical quantum computer. So that is a big date for us. We're working with our clients on building this infrastructure and applications to meet that need in just 2 years. Next slide. So, and this amplifies the message that that's why clients are working with us now in anticipation of this crossover into quantum utility. You know, another interesting thing is we've moved away, in a practical sense, we've moved away from the conversations about quantum advantage, because from an executive's perspective, if quantum computing applications offer 2% improvement, 5%, 10%, right? And that translates into direct dollars. That's what they care about. They are not focused on that theoretical quantum advantage conversation that we used to have about 5 years ago. So it's a very interesting evolution of the dialogue that we're having with clients. Next slide. I wanted to show you this. This comes from a Zapata study that came out last year. And I want to point your attention on the left to the range of industries, from manufacturing to energy to telecom, you know, transportation, biopharma. So we're moving into a space where all of these types of companies are coming to us. And even manufacturing, we have preventative maintenance use cases in progress. And you see there the colors kind of, it's a little bit garbled, I see on the slide, but some are more advanced than others, but they're all approaching us to have a dialogue on how they can move forward in their quantum journey. Next slide. This is another theme I thought that would be very important for you to be aware of. In the evolution of applications, right, we know that commercial applications are becoming hybrid. Quantum computing is part of that. So you can imagine a machine learning pipeline where part of the work, you know, some of the subroutines are sent to a GPU, a CPU, and a subcomponent is routed to a QPU. On top of that, within the quantum application itself, there's also a hybrid loop of classical and quantum computing. The optimization loop, for example, in many machine learning algorithms, that can be handled and split up between the quantum computer and the classical computer. The third layer of hybrid is in operating the chip itself, right? The equipment that drives the lasers that operate on these ions is driven by a classical framework. So I think it's important, especially for this audience, to know that quantum computing and classical computing are complementary, right? Let's use each type for what it does best. Next slide. Gary, if you would help me keep my time, that would be great. So on the next two slides, I wanted to dig a little bit deeper on the technical differentiators, you know, for those of you much more technically minded. So focus your attention on the left first. The fact that we're using perfect qubits. Ions are naturally quantum object. They want to remain quantum. I don't have to induce quantum effects in them through engineering, right? This means that each ion is perfectly identical to the next ion. If I have 32 ions in my chip, they are fungible. This is dramatically different than, say, superconducting qubits, where each qubit is individually manufactured and needs to be individually calibrated. The bottom line here is that there are low errors in the qubit, and that affects me as a developer in delivering good application results to clients. The next bullet point there, the best coherence times. Coherence means how long is the quantum resources, how long are they available to me as a programmer? So if I want to use entanglement, how long is that entanglement resource available to me in my program? So you want long coherence times. We have the best in the industry. And then moving on to the right, the better gate fidelity. When you want to execute a line of code on a trapped ion quantum computer, such as those that we deliver at IonQ, the line of code is translated into a laser pulse with a certain frequency and phase, and that laser pulse is directed at an ion, right, an ionized atom, and it changes the state of the atom. And so the better your laser is calibrated and focused directly on that ion, the better I'm going to be able to execute my code. So that's what that means. Better gate fidelity means how well is my code getting executed in the quantum computer. And we offer very, very good gate fidelity and getting better and better. Lastly, the low spam errors. This is a kind of a detail in the quantum computing space, but you need to prepare the quantum circuit, you need to prepare your data, you run your program, at the very end, you take a measurement, you're getting the results out of the quantum circuit. So these processes, sometimes introduce errors depending on the architecture. In our design, we have very low errors for at the start of the program and at the end of the program when you get your results out. What I want you to take away from this.
Jump to the applications.
Sorry?
Maybe we can jump to applications before we run out of time.
Oh, absolutely. So the quality of the qubit matters. Let's move, we'll skip the next slide. I just have and keep going. We'll skip this one too. Right here, and this is the last slide. So this is a panorama of the applications that we're delivering to clients. On the left, you see two around risk management, correlations, right? Those are tied together, all centered around generative adversarial networks. So this is a cluster of techniques that we've developed that are giving results because of those low error qubits. Then we have with Airbus an optimization use case. This is for combinatorial optimization. We've delivered a bunch of techniques in that space. On the right, chemistry, of course, materials science. That is a whole cluster of other work that we've delivered, whether it's around lithium ions, lithium batteries, or in hydrogen fuel cells. 3D object detection and image processing. This is a cluster of techniques around using image data, LiDAR data. So what you see here, we cover time series data, image data, chemistry data, right? And finally, at the end, we're moving into the space of manufacturing, doing things like predictive maintenance. So what I'd like you to take away here is that a lot of data science use cases that you're familiar with, there's a component where you can add some quantum computing. Next slide. We'll skip this, and I think the next one is my last slide. So please visit our website and let's open it up for questions.
Yeah, so let's talk a little bit about, our interest in the fiber industry obviously is that as we get fiber to every community across the nation, it allows us to be able to have quantum networking. And quantum networking not only has ultra secure secure communications, but it also provides a pathway to cloud-based quantum computing. So in essence, this level of quantum computing could be available to everybody on a cloud basis. Is that the way we should look at this?
Yeah, in fact, we offer our systems and our software, access to systems on all three clouds. So Google, AWS, and Microsoft, or you have the option of coming directly to our cloud as well.
So we are only a couple of years away, right, from actually this being a reality as far as people, the average business being able to access quantum cloud computing?
That is our roadmap. You know, we are working laser focused on delivering on our roadmap, and we anticipate there to be an important inflection point in about 2 years when we have 64 qubits, especially because you can't simulate 64 qubits on classical systems. So at that point, you will have to be working on a quantum computer.
So areas that are really going to, I guess, accelerate or have quantum leaps, I'll say, are areas like any type of like artificial intelligence, machine learning, imaging.
That is where we anticipate that we're going to see, and what we're seeing there is that the quantum machine learning models, whether they're generative adversarial networks or convolutional networks or reinforcement learning, right? Any of the machine learning models, they're more compact, meaning they have less parameters in their definition, and they converge to the cost function converges to a minimum much faster. They also generalize. You know, in some cases, we're seeing evidence where they generalize better. That is directly attributable to quantum resources such as entanglement.
So like, for instance, genome sequencing, you know, if we're able to leverage quantum computing to bring down the cost and be able to have rapid genome sequencing, we could be able to have gigantic advancements in just health, right? Being able to predict diseases, be able to understand what medicines that we can take that are going to be useful and beneficial versus harmful and caustic. And...
I mean, we're seeing discussions around that, but in a practical sense, we're not working on any use cases in that area in particular. Where we're working is in the life sciences, for example, in rare diseases, where they don't have as much data to represent that rare disease. And so we would love to collaborate with a company and augment that data set, because a quantum circuit is a natural generative learning framework. And so could we model that underlying process with fewer data points, and then be able to generate similar data to augment that data set for classical machine learning. So we're moving into the life sciences and doing work, but certainly not yet in genome sequencing. That's something we anticipate to be in the future.
Well, my favorite quantum physicist, Michio Kaku, likes to say that we're going to be the last generation who dies. So we'll be able to, future generations will be able to 3D print.
Live forever.
All that stuff.
Yeah.
So one of the questions, a lot of our applications are hosted in Microsoft Azure Cloud. Is IonQ working with Microsoft to offer its quantum computing platform in Azure, especially for hybrid applications?
Yes, we make our systems available, not the latest systems, those are reserved for larger clients, but in general, we make systems available on Microsoft, on Google, and also on Amazon. And of course, you can come directly to us. The advantage of coming directly to IonQ's cloud is we're able to reserve some time for you. So you can block 4 hours to run your job, as opposed to being in a queue, like in a public queue. But please reach out to me if you have any questions, and I can help you kind of sort out where to run your jobs.
So a lot of great questions here. So you might have to hit some of these afterwards, but specifically in reference to digital twin applications, to be able to create virtual networks for design possibilities. So is that an application? Can quantum computers create
around that? Yeah, we are looking for how we could supplement. You can imagine a digital twin might need a module, within the larger framework. It's kind of a big data problem. So quantum computers are not currently used for big data problems. That will likely remain in, deep learning frameworks in the classical sense. But there could be a subset of functions that we can run on a quantum circuit. For example, the framework of quantum mechanics, the mathematical framework of quantum mechanics, lends itself better to understanding human behavior. And so you can imagine either in large learning models or a digital twin, you could implement a quantum computing module that would add something special to that environment that you can't implement on a classical system.
Well, Nicole, just really appreciate it. Thank you so much. We're so excited to learn how, fiber is going to be ushering the new quantum age and how it's going to benefit our society. And I want to thank everybody for joining us today, and look forward to getting back together next Wednesday for Fiber Breakfast with the Fiber Broadband Association's tribal broadband chairs, Sachin Gupta from CenturyNet and Robert Griffin from the Choctaw Nation, to discuss tribal broadband opportunities and challenges. So you're not going to want to miss that. So thanks, everyone. And
my pleasure.
Nicole,
bye, everybody.
You can follow up on some of these questions. We got a lot of really good questions here at the end. So thanks, everyone.
I will send them to me. Yep.